Recursion is one of the most important concept in computer programming. So what here we do is we call the same function again and again. So we have known to we have written some functions, so we can write some functions. Okay, so if we write a function for integer, say func a, okay, and we can write another function func b, and we can call the func a inside this function. Okay, so we call this function. So when you run this code, so if you so in the main function, if you run this function b, so what will happen is when you come here, it will call this function. So when you come here, it will call this function. So this one is straightforward. So we have done this again and again. But what we can do is we can do this something. What will happen here is so we have the main function, and when we and our programming controller is at this function. When you call this function b, it will go to the programming counter, or the programming controller goes to the function b. So then we will start with function b, and when we come here, what will happen is we will call function a. Okay, so from here we go here, and from here we go here, and from here we return to this function, and when this is finished, we return to this function. So we will do something like this in the computer. So if you have some variables here, okay, so these will be local variables, and here also we have some variables. It will be visible only to this function. So the memory will be declared in this stack memory. In the stack memory, you will declare your local variables corresponding to your functions. So now we can do the same thing with the one function. So we have a function, say whatever, func c, okay, and in the main function we can call this func c, okay, and here inside we can call func c again. So what will happen now? So in our main function, we have the main function here. Okay, from main function we call function c. So we will have memory or space within the function c will be called into the memory programming counter, and then when we come here again we call the same function func c. So the program will start again here, but this will be a new copy of this same function. So it's similar to this one. So from here we will call this function, and similarly when you are here, when you call the same function, it will run a new copy of this function with this new memory allocated in the function. So you can see now, so this is this will become an infinite loop. Okay, so this is become infinite. So this will run over and over again. So this is we call recursion. So this will run over again and again. So so if you use recursion in our program, we have to avoid this infinite loop. So we have to have a termination condition somewhere. So if you call over and over again for every time, it will be infinite and your program will stuck by calling in infinitely. Sometimes your memory will run out because you have to have your memory allocated for all the functions, and so that one can happen. So but this recursion we can use with this termination condition and some other techniques we can use to solve various kind of problems. For example, so if you want to find numbers, the sum of numbers from 1 to n. Okay, so how do you write this function? So you have to have a function, say sum, and you pass integer n, and from here you create a variable result or something like that and make it 0, and then what you will do is you have to have a loop for integer I equals 1, I less than or equals to n, I plus plus, and what you do here is sum equals sum plus I, so you will add all these numbers and return result. So this solution we call iterative solution. So we iterate, so we do a iteration. So if you can have an iterative solution, it may be more efficient and fast sometimes, less memory. But some problems, write an iterative solution may be very complex. So we have to use other techniques to simplify this and get the solution. So one of these techniques is recursion. So we will see how to do this with recursion. Okay, so this is our recursive solution. So you can see now, so you have the function sum, and it takes, you can see a number n, and then you can see the function calls the same function sum inside this one. So you can see you have the recursive function. So you have so this is where we have recursion. Okay, so but you can see now when we are using recursion, we are, so here we have n and here we have n minus 1. So so what we have here is, so if you use recursion, we have to have two things. One, the first one is the recursive call should be simpler. So when you do this, after some times you can, so the next time it will be n minus 2 because it will be simpler with this one. So you can see if you have the function n and the recursive call is 1 less. So you can see when you have the recursive call from here as well, it's n minus 2, n minus 3. Likewise, it will go until say 1 if you start with a positive number. So then the second condition is you have to have a termination condition or solution. So our termination solution is, so if you have n, then we know the sum, n is, if the n is 1, we know the sum of 1 is 1. So we have the So this is, we have the solution for termination call. Okay, call. So we should have, if you are using recursive call should be simpler, and we should have a termination condition. Otherwise, you will not be able to use this in the solution. So we will see now how we can, how this is called. So you can see, so I will go to the other part, sorry, other side, okay. Okay, so I will draw our memory. So we have our memory. Okay, so first we have the main function call. So we have two variables in the main function. So one is num and the other one is answer. So you can see the first variable is assigned 4. Okay, the first variable is assigned 4, and then you have the next call. So now after allocating these variables, it will call this function sum, and now num is 4, as you can see. So the program will allocate memory for our new function, which is sum, and the input variable is 4. So in this function you can see you have only one variable n, which is now will be passed with this, and the variable will be 4. Okay, so now you can see it's not equal to 1. So the variable is not equal to 1, and so it will go to the else part in that function, and this will be 4, n will be 4 now, and so it will be in this line now, 4 plus sum n minus 1 is 3. So now again this function is called, so you have a new function call, and the program counter or the program control will come to this function, and here also you have a new memory space, and this is a new function which is a copy of this function. So, and the variable n will be local to this function. So this function, new function, and the value will be now 3. So now again it will check whether the n is 1, it's not 1, and then it will come into here. So I will use a new color, and n plus n is 3 plus sum n minus 1, 2 will be called. So now, so with this we will come here. So here answer equals sum 4 was called, and sum 4 came here, and then sum 2, and then you will have sum 2. Okay, so keep it here, sum 2, and n will be, new n variable will be created, and now n will be 2. Okay, and so it will go to the else part again, n plus sum n minus 1, 1. Okay, so now this sum 1 will be called because it's a new functional call, and you can see new memory will be allocated. It's a new copy of the same function, and you can see new n variable which is 1 will be allocated. Now n is 1, so now you can see it goes to the if part, true part, and this will return 1. So now, so this will return 1. So where it will return is the issue. So we call this function here. So it will call the return value to the in front of this function. So usually we can say x equals some function. Okay, so the value will be returned here, and it will be then, if you have an assignment operator, it will be assigned to this one. So the value will be returned to here, and then so it will be so this is return. Okay, so value will be 1 because it's returned 1 here. So 1 plus 2 will be returned again, and now so this function was called from here. So it will return the value to here. So the value is 1 plus 2, 3. So 3 will be returned here. So now again this is also returned. 3 plus 3 is 6, and the 6 will be returned here. Okay, and again this is returned. We add the return statement. This function was called. So 6 plus 10 is 10, and this one will be returned here, and because it's unsequal, so the value will be 10. So this is how this statement, the recursion works. So you can see when you call recursion, okay, so you call like that, and then after some time you start returning in the same path backwards. Okay, so this is how return works. So start with the starting point and go to the termination point, and then come back to the starting point. Okay, so we will see how we can write several programs using recursion in C++. Okay, so we will start writing our function. So we have a number equals 4, and then we have to have the answer, and we have the function, and we will pass our variable num to this function. Okay, and then we need to print the answer. Okay, and then we have to write our function now. Okay, so it should return a value, integer, and the name should be sum, and it should pass n, and then so first we need to write the termination condition. So now termination condition is if n is equals to 1, we should return the answer for this termination condition 1. Else we should recursively call our function, but the issue here is we have to call, so we remove this because we need one line. We will return n, the current value, plus then we have to add all the numbers from 1 to n minus 1. So from 1 to n minus 1 is sum n minus 1. So now we can see we have written our function here. So now we will run this one. We in the command prompt. So we will compile first. So we will use the genome C compiler, C++ compiler, and the output name is say sum. Okay. And it's compiling, or it's compiled. So now we can run, and it will print the value, the answer as 10. Okay. So now we can see our program is running, so it print the correct answer. Okay, so now we will write another program, which is one of the famous programs, is finding the factorial. So factorial is from n minus 1, so you multiply n minus 2 until 1. So this is the factorial. So we write this as factorial n. So we can now, so factorial n, so I will write factorial n. Factorial n can be written as n, so we have to write this as a combination of other factorial functions, because we are going to use these recursions. For recursion, we need to be able to explain or express the solution of a larger problem by a smaller problem. So you can say factorial n equal to factor n by multiplied by factorial n times 1. So you can see this part is factorial n minus 1. So now you can see we can programmably execute this one like this. Okay, so this is our recursive functional call, but the problem here is how to stop it. So we need to stop. So n equals 1, we know the answer, factorial n, that means factorial of 1 is equal to 1. So we can stop here. So factorial 1 is 1. So now we can say it is similar. If n equals 1, return 1, else return n into factorial n minus 1. So this is similar to finding the sum. So we will write this now. So we will remove this, and so our answer is, so we will ans is, so we will write the factorial function. Okay, so we are calling the factorial function. Now we have to write that factorial function, factorial intn. So now it is similar, intn, if n equals 1, what we do is we return say 1, else we don't need this much, return n multiplied by factorial n minus 1. Okay, so now this should be working. So factorial 1, 2, factorial 4 is 1 multiplied by 2 multiplied by 3 multiplied by 4, it's 24. Okay, so we will compile this. Okay, so it does, it needs some values. Okay, we'll see. Okay, so you can see now the answer is 24.